Hi everybody, happy Monday. Here we are. So today we're going to actually answer Jennifer's question. So what we're going to do is actually make equations of a cubic function. Now this one has a very specific answer because it has to go through this point right here. So today's objective is finding equations of polynomial graphs. Now this one's specific. Now so we talked about it and about how Jennifer actually brought it up about how many times you could have many answers. So if we didn't have this point right here and all we knew were just the zeros. So I know my zeros are at x equals 1, 2, 3, 4, negative 4, x equals negative 1, and x equals 2 are my zeros, right? So if that's all we knew, then the graph might look like this, could look like this, right? Could have lots of different answers. However, this one in particular goes through a given point. So finding equations of polynomial graphs through a given point. So we can actually find the equation of this particular one because it goes through a point that we can find. So the point we can find is right there, and that's the point at 0, negative 2. And we're going to come back and use that. So let's start off with the equation. So I do know this, that I know that to get an x minus 4, I would have had to have an x plus 4, right? Mini equation, that'll give me a negative 4, which corresponds to this 0, okay? I'd have to have an x plus 1 in order to have a mini equation to get an x equals negative 1 to get that 0 right there. And I'd have to have an x plus 2, minus 2, my bad, x minus 2 to have a mini equation to give me an x equals 2, which is that 0 right there. Now, what we don't know, though, is the value of a. And the value of a is really important because the value of a gives it its shape. So what we want to do is find the value of a, but we're going to make sure that it goes through the point 0, 2. So we're going to use the point 0, 2 in my equation to find out the value of a. And since I'm using the point 0, 2, then I will end up driving it through this point. So here's how it happens. So I know every point has an x and a y value, okay? So I'm going to take 0, and I'm going to take my 0 for x's. I'm going to plug it into all of my x's. I'm going to take my negative 2, which is my y value, and I'm going to plug that into my y. So let's rewrite this. Instead of y, let's write the y value, which is negative 2. Instead of writing x, let's write the x value, which is 0. Instead of writing x, we'll write the x value, which is 0. Instead of writing x, we'll write the x value, which is 0. And let's simplify it. Let's find the value of a. So negative 2 equals a times, let's see, 4 times 1 times negative 2. So I've got 4 times 1 times, that's a negative 8. Okay, solve, divide by negative 8, divide by negative 8, and I get an answer of 1/4, positive 1/4 for a. Now I'm almost done, because what I want to do then is take this 1/4 and put it right there. So let's rewrite the equation. Let's write this. Let's go y equals a 1/4 times an x plus 4, x plus 1, and x minus 2. And that will be the equation of that cubic function. Okay, example 2. Example 2, you don't really need a picture. Now, if you want to draw a picture, you could, because we're going to do the exact same thing we did up here. 1, 2, 3, 1, 2, 3, 4, right? But it goes to the point 0, 4. So it's probably going to look something like this. Okay, so I know for sure a is going to be negative. I know that just by the shape of the graph. But let's find the equation. So again, to have an x equals 3, it had to come from an x plus 3. To have an x equals a negative 2, it would have had to come from an x equals 2 has to come from an x plus 2 equals, sorry, x equals negative 2 had to come from an x plus 2, and finally x plus 4 to give me the negative 4. Okay? So to give it the right shape, we have some value a that will probably be negative in this case, and we need to find the value of a that makes it go through the point 0, 4. So the point 0, 4, that's my x, and my y will do the exact same thing we just did. Plug in the 4 for y, 4 goes in for y, we'll let the x's be 0, let the x's be 0, let the x's be 0. We'll get a 3 times a 2 times a 4. Well, that should be a negative 3. Hold on, Mr. Davies. Had to be negative 3 to get the positive 3, and it had to be negative anyway. So 4 is equal to, let's see, that's a negative 24a. Divide by negative 24. I'm going to reduce this as a fraction, negative 1/6. So my answer is going to be to take the negative 1/6 after I reduced it, put it right there, and my answer as an equation is y equals negative 1/6 x minus 3, don't make a mistake, x plus 2, and x plus 4. And that will be the polynomial that has this kind of shape right there. Okay? Second page, example 2. Say, right now we get this 2 plus I passing through 0, 2. Well, here's what I know. Okay, I know that these come in pairs, 2 minus I. Okay? I know they come in pairs. And what else do I know? Well, I know that I'm probably going to have some kind of problem that looks like this. Okay, I'm going to give you a sketch. 1, 2, 3. Yeah, it goes through the point 0, 1. It's probably going to look something like this. Probably something like that, where it only goes through once at 3, and it doesn't go through again because these are imaginary roots. So let's go ahead and figure this out. So first of all, I'm going to have some x minus 3 gives me my 3 as a mini equation to give me a 0, 3. Now these two, though, I'm going to use my special formula, x squared minus the sum of the roots plus the product. Okay? And I'm going to have to then have a sum. So if I take my sum, because I need to fill this out, I need to find out the sum, that number, which is going to be to add. So I got a 2 minus 2 plus I and a 2 minus I, and the sum of those, that's easy, is 4. So here we go. I got an x squared. I'm sorry, an x minus 3. I have an x squared. I put my 4 there, minus 4x, and then I need the product. Well, the product is multiply, right? Product means to multiply. So I'm going to take my 2 imaginary roots, 2 plus I, 2 minus I, and multiply. I get my 4 minus 2I plus 2I minus I squared. Those cancel. I've got 4 minus, I know I squared is equal to negative 1. So I get an answer of 5. Okay, now, here's what I have so far. I have y equals, but I've got to have some a value. It has to go through the point 0, 1. So I'll do the same thing I just did. I'm going to take my 0 and plug it in for my x's and put my 1 in for y. So I'm going to rewrite my 1 in here for y and my 0 in for all of the x's. So let's see what I get, okay? So I'm going to have a 1 equals a times 0 minus 3 times a 0 squared minus a 4 times 0 plus 5. I get a 1 equals a times negative 3. That's a 0, 0 times 5. I get 1 equals a negative 15a. I'll divide and I'll get negative 1/15 for a. So now I'll take this answer, I'm going to plug it right there. Okay, so my grand answer, I'm going to have to squeeze it up here. Okay, I can do that. So my grand answer is y equals a, which is negative 1/15 times x minus 3 times x squared minus 4x plus 5. We'll talk more about this in our Zoom meeting. Okay, so there you have it. Okay.